And discriminator try to discriminate the real image from the fake or generated image. So in a time, generative model try to train and learn and became more powerful and produce or generate images that look like more real. And discriminator networks try to make it himself powerful to discriminate the real from the generated one. So we have a game, two parts in the game we have. One part try to improve to generate images more look like real ones. And discriminator try to recognize even the better generated image from real one. So, in the last of the game, generative models generate images that look like real ones, but they are not these images, but look like them. So that's why if generative image model generate images similar to Chinese, that means we generate Chinese faces. Maybe that's the fake. That's not inside the Chinese, but look like the Chinese. That's the fundamental concept of the generative models that we talked in previous session. So here we have a neural network here, a neural network here. So the neural networks that we have here gets image as an input. The output is one value, 1 or 0. If it is 1, means the image input image the real. If it is the 0, means the input image the fake. But this one get a vector and draw a neural network, output an image. So we have two neural networks, one of them gets an image, give us one value, 1 or 0. 1 if the input was the real one, 0 if the input was the fake. But the generator gets and the noise as a vector and convert it to an image. So with the neural network. Then we talked if instead of neural network we use convolution neural network CNN, that in that case the generated image look like more real. They are look like they are more real. So we go to next concept. That's the convolutional gap. So to talk about convolutional gap, that's this part. In the generator, we started from a vector, noise vector. We output an image in the generator. So we started from a noise vector. We reached to an image in the generator. But in the discriminator, we start from an image and reach one value, 1 or 0. If it is real, 1. If it is fake, 0. So now we are talking about the generative models, starting from a noisy vector, then generate at last an image. So to generate an image, we will have networks. Instead of usual neural network, we use convolutional neural networks. We convert it to make it an image. We will see how. So to talk about this concept, we return to concept of convolution. In the convolution, if you remember, we have an image. We apply a filter. We will have an output. This output, we call it filtration of this image or combination of this filter on this image. How we do it? For we overlap filter on this image. At first, it will be like this. So when it is like this, I write here 3, 5, 1, 7, 2, 7. So you say this one?
4, 1, 3, 8, 6, 3, 8, 2, 9, 6, 1, 5. 1, 5, 1, 5.
1.
لا هو ده ياخدها كلها. هسه راح يستقطع منها تحسب 3.
So, and about filter. The filter is
1, 2, 1,
1,
2, 1,
1,
2, 1, 2, 1, 1, 2.
1, 1 is the filter. So when we apply a filter on an image, we come at first we overlap filter in this area. So this filter and this one will be overlapped. And any pixel, any pair of the pixel value in the filter and in image means this one and this one is a pair, one pair of the values. So one in the filter, one in the image. Those will be multiplied and we will have 1 multiply 3 became 3. 2 multiply 5
10.
became 10. We have all of them and then we sum all of them, aggregate all of them, and the result, here the result is 55. So we eliminate this and we put 55. So 55 is addition of the multiply of the pair of values in the filter and the image. So now we have 55. Then we shift the filter. It's became like this. Again, we overlap filter and this part of image, and all pairs from filter and image will be multiplied. For example, here 1 and 5 became 5, 2 and 2 became 4, 1, 7 became 7, and all of them. We add all of them, became 52.
شفتها بعد جوال تصير 4 مقاطع.
انتبه.
So the same we do for the shifting of the filter window down.
لا.
So it's became so again we overlap the filter and this side of the image, and all pairs such as 1 and 1 will be multiplied. This became 1, this became 6, this became 2. So all will be added, will became 57.
57.
After that, we shift in the right. So we will have these parts. We overlap the filter and the side of the image became 1, 6, 1 bar, 2, 5 became 10. We add all of them became 50.
15.
This is applying a filter on an image. Here also we see this part of the image multiplied any pair and then added all of the multiplied value result became 55, and also we do that for the other part of the image. So this is the combination. Means every time we try to make the image smaller. But here in the generated part of the generated models, we starting from one vector. For example, the vector size is 100 value, and to reach an image with the size of 64, 64, 3, it became so much larger than this. So we try to make it the image or the inputs larger. So in that case, instead of convolution, we should apply inverse convolution. We call it deconvolution. We will see how it is in the mathematics. So we want to do deconvolution. In deconvolution, we don't have this part. We have this part. We want to have this part. So input is this one, output is this one. Instead of the previous slide, that we started from this, we applied this filter with the combination, we reached to this part. So here, we want to do the inverse process. So we started from this one with the deconvolution and this filter reached to this one. So we see how it is possible. So the process is defined like I am talking now in the mathematics. So we multiply the input on the same filter pair by pair. Means any points is overlapped with this one, and all pairs multiplied together. And after multiplication, we don't sum them. Just we multiply the pairs and we put it in the pairs. What does it mean? So now we don't have this part. We have this one, we start with this one, and we have filter. So, at first we multiply together these two, and we will have a result. We put it, so here, this red one, the blue one, black one, and dot blue. Dot blue. So, at first the red one, we multiply this, became 55. 52 multiplied
110. 110.
110.
55.
52. Oh.
55 multiply 1. No, doctor.
Sorry. 55, sorry.
أفارن زينة.
One mistake. I just grabbed it.
At the last after me.
So, from this part and multiplied on this, we reach to this value.
Yeah.
So in the inverse, we multiply this value on this filter and reach this. Exactly the inverse process.
Okay.
So that means here we multiply 55 on all of them and we put it here. So 55 became 102.
55.
10 and 55. This 2 multiplied 55 became 110.
55, 110, 55, 55, 110.
So, now about the black one. The black one is 57. Means from this box and this filter we reach 57. We do this inverse process. We multiply 57 up all of them. So between
57,
plus 57.
114,
This 100.
114, 57,
Sorry, 100.
114,
Wait.
دقيقة تنجم عطوة وهذا
So the black one started from this. At first 57. So inside the black. So 57 multiplied
114,
then
57.
multiplied on 1.
57,
Those part that has overlap of red and black, I don't know, the blue and so on, those overlapped value will be multiplied.
right.
So here also
114,
this
57.
This multiplied on this.
57,
Then
100.
this multiplied on this.
114,
So after that is
57, 57, 114.
So here we have one value, so we don't have addition.
Distribution.
100.
114. Get it.
So
There.
and the length exactly the same. The result will be like this. Here 57, 57, 50.
Now, we must to finish all the
I think
matters.
that
Then add.
okay. Good. This will be added. This will be added
No.
with the blue one.
Just two parts.
But this part will be the same because it's finished. Those parts that finished, we finished the black and red one. Those one is the final values.
Then
But those parts, dot below and the blue, so we didn't finish, they will change. But this part is finished, so also this part is just red, so this will be 55. This is 167. This one 169, and this one 57. Enough, or we continue?
That's clear.
That's clear.
no, just a question. When you finished all the statement, then
We will have this.
the finished statement,
This-
we
this
choose
will be
the lower number or what?
You see, we multiply 50 on this,
Yeah,
we
Yeah.
put on dot below.
yeah,
Then any parts we have, for example here, we have overlap of blue, red, and black. So this part we will have 3 numbers.
yeah.
Will be added. Those parts we have just one
One number,
value, no need to add it. So that will be the final result. This one.
Oh, get it.
فهمت المشكلة؟
فهمت.
نشرح لنا
ونشوف عادي.
ها
تريدون
يشرح
نشرح لكم اياه؟
وهو الاخ
ترى
مو شرح.
So now
تريدون
we
نشرح لكم
talk
اياه؟
about Shetinet. Look.
يلا الله يعافيك شوي علي صوتك.
هاي الحالة سوينا احنا اخذنا هاي 4 ثلاثة بثلاثة.
جيد.
فسوى هو الأستاذ قسم كل ثلاثة على الفلتر، بلش زحفة هيجي على الفلتر، وزحفة هيجي ويا الفلتر، وزحفة هيجي ويا الفلتر، تمام؟ نضرب كل يعني عنصر وعنصر عشان صفة نهائية.
شلون نضرب بس؟
ها.
خذي قلم، تجيب قلم هنا عندي.
ما يحتاج.
يحتاج؟ عندك قلم؟ ما.
هسه بتجي 3 في 1 زائد 5 في 2
آه.
إذا بدنا نجمعهم كلهم يصير عندي ال 55.
عيدي شلون عيدي؟ 3 في 1
في 1
أي.
5 في 2
أي.
2 في 1 كلهم نجمعهم بالنهاية
اي
عندنا 55.
تمام.
نفس الحالة هذا البارت 3
أي.
الفلتر كنا عندنا 52.
اي
هذا البارت 3
أي.
الفلتر كنا عندنا 57.
جيد.
وهذا البارت 3 الفلتر كنا عندنا 50. أول حالة.
نيكست.
هسه ايش سوى؟ اخذ هاي 55 ضرب بالفلتر كله
بالعكس سواها.
بالعكس 55 في 1 55 55 في 2 110
حلو.
55 في 1 55.
اي
ضرب هذول كلهم وعندنا هاي البارت وحده.
اي
هذا البارت جوا شوفوا 57 في 1 57 57 في 2 114 57 في 1 57 وهكذا كلها تمام؟
هذا اللون هو يحدده الاصفر.
هو نفسه الفلتر ثابت.
فلتر ثابت يضربي.
وعندنا هاي الصفة الأصلية ثابتة،
أي.
تمام؟ ايش سوى؟ أمن هاي ثابتة وهاي ثابتة، بس رجع بالعكس يقول لك ديكوبريشن، بالعكس رجع ضربها، تمام؟
تمام.
رجع هذا البارت 52
أي.
في 1 52 52 في 2 104 52 في 1 52 ضربها كلها بالفلتر طحنها مالته. وهاي الحالة نفس الحالة 50 بالفلتر وأنتج هاي.
تمام.
بالنهاية صار عندي هذا البارت 55 أحمر. وهذا البارت الاسود مال 57.
تمام.
هسه من زحفه طلعنا شمال الاخير 52.
تمام.
وزحفه هذا المقطع اللي يوحدهن
اي
افلاين عفا ما يلعب بي الوحده عافه الوحده عافه بس عندي صار هاي بالنص يعني صار 4 قيم بي انه صار عندي هذني الاثنين وهذني صار مشترك. المشترك شو يسوي بي؟ يجمعهن قيم 110 ويسبقى 50 ويا نفس
نيكست.
عندنا مشترك مع القيم المشتركه اللي بيطلع لنا بالزني معهم
اي
جمعهن تبع الحافه ما تغيرت عندي هاي بقت القيم المشتركه اكثر من قيمه جمعهن طلع عندي شيء نهائي اللي مثل المشتركات.
This one is the stake, no?
Yeah. That's it. سؤال؟
ها؟
الجمع ما طلعت سنة.
لا
طلعت.
معناها
لا هو حل بس وصلنا حل بس حالتين. لأن كمل الحل بقيت الحال الذي الأربعة اللي عندنا. تجمعهن أنا جمعتهم مع صحيحات.
جمعت كل شيء.
شو جمعنا كل شيء؟
جمعت.
ضرب مصروفين.
لا الجمع.
الأخير هاي آخر حالة الحالات المشتركة.
العيد الرسم. اي تمام.
يا حبيبي.
أول كلمة.
بنص.
على الأولى.
يلا.
كانت بها جمع.
هلا قام الفتحة.
أنا ما عندي هذا كله ما أدري طاني هذا الرقم وطاني هذا
تمام. اي ابن اختي.
بما أنه 4 الصورة اللي تنتج لي لازم 4 في 4 تمام؟
16.
مصفوفة.
Yeah.
حاول شوي تاخذ طرف اليمين حتى التصوير يكون افضل.
طلعتي 4 في 4 بناء على اللي هو البنطاني.
جيد. ممتاز.
تيجي تطلعهن واحد واحد. هذا تضربه في الفلتر.
كله؟
اي
اي
يعني 55 في 1.
اي 55. تمام.
55 في 2.
100.
55 في 1.
اي شمس.
تنتقل للثاني.
اوكي.
او طبعا تسلسل
طبعا
52 في واحد
52.
بس هذا مكانه وين صاير؟
لا الطرف اليمين.
إيه، هسه انت اي فكره
الطرف اليمنى.
هذا المكان مالته.
حلو. ناخذ ايش قد؟ 4 ناخذ حق مصفوفه كامله ونخليه بالزاويه 52.
ثلاثه في ثلاثه
ثلاثة في ثلاثة.
اعطاك اياها
اعرف 3 في 3.
بروفايل سلايد.
بريفرس سلايد. اي هذا شوف
أي.
هذا الاصلي اللي طاناها
جاي شوف هاي.
3 في واحد
ايه
52 في واحد 52
عيدها ما افتهمتها. اعتبر دماغي ثخين.
لا كمل المصفوفة الأولانية من 55 حتى نتحول حتى
يلا.
يفتهمون هاي.
تمام. ايه
55 في 2
110.
110.
أحاول لك على السريع. 55 110.
اكتب اكتب
لا
اكتب.
اصبر 55 في واحد
أوسع.
الثاني 110
55
هذا 110
110.
55
55 في واحد
55 55
55 في واحد 55 110 الاول كله خلصنا من عنده.
دفعناه.
بالتالي 57 او 52
52.
انت تريد تشتغل على هاي
ايه
الشغل
اللي بصفها
غير اللون. غير اللون. غير لون القلم.
بس نفس الحكي شرحته.
52 غيره
ايه 52.
52 في واحد
52.
هنا تبلش
تمام. نزحف مربع
شوف
كامل.
بعدين منتجنا الرئيسيه الكبيره
جيد.
52 في 2 104
امم
52 في واحد
150.
104 52
52 في 2
104 52 من
52 في واحد
104
لا تلاحظ مثل الاوليات كل واحد هذا يبقى واحده مالته لين
ايه فهمتك. ايه وضحت.
52 في
52 52
104
جيد.
هذا خلاص منه تنتقل على 57 وراها
جيد.
57 في واحد
لا فوق فوق.
فوق فوق فوق.
57 في واحد
هاي ثلاثه ذني مال هذا
اوكي.
57 في واحد
سوي لكم جوا.
ايه
57 في 2
104
هنا هم تجي وياها 104
14.
114
14
57
في واحد.
واحد لا 57
امم
57 في 2
114.
57 في واحد 57 في يطلع 114 57 في واحد 57 في 2 114
جيد. بغى 50.
50 هم تضربها في هذا مكانها وين؟ ذني الثلاثة
يا هنا.
هاي الثلاثة
فهمتك.
نفس الفصل الأولي
أوه.
يقول لك تضرب ذني الثلاثة
إيه.
الفلتر يطلع لها القيمة
خوش
فبالترجيع هم نفسها 50 هاي مكان ذني الثلاثة
خوش.
تجمع المشتركات.
الزاوية تقول 50 والزاوية
الزاوية 55 هاي الزاوية
اللي رقم الوحدة تبقي.
بعدين الجمعة
تجمع بالخانة الواحدة.
هسه هاي القيمة ال 50 راح تضرب بالواحد مو تجي هنايا
ايه
يعني راح ينجمع ذن
مثل
كل عندك 4 قيم اذا راح تشوفها قيمة كبيرة تصير
إذا 110 زائد 52
50 في واحد ناخذ ضيفها
هاي التسوية
50 في 2 عندك هنا 100
ايه
50 في واحد
50
50 في 2
ما بامتحان البوكسيات.
شوفها ناس
بس أنت تفتهم ايش دا يصير.
ايه
50 نفس
50
100
وهنا عندك 100 50 50
50 50
تجمع الأرقام.
ايش تجمع يا هي؟
كل خانة تجمع الأرقام اللي بيها.
55 تنزلها.
110 100
و52
52.
106 1.
هاي 2
هاي تبقى 52.
104
تمام.
164
159
50
1 5 9.
امم
ذاك يبقى نفسه 52.
هذا بس الاولي.
اول شيء ضرب مو جمع. تضربها
هو ما ضرب بعدين جمع.
تجمعهم ضرب جمع كل لاين ضرب جمع. ايوه لا تضرب هيك شيء تجمع هيك شيء. شوف
لا طلع لك هاي.
هذا تضرب هاي ضربناهن زائد ضربناهن عمودها صف تجمع هذه هاي. اي لا شوف بروح هاي بعد اي هسه اسوي لكم اني الطريقه مبسطه وادزكم اياها واضحه.
طيب جماعه كل وحده نزلت.
فهمتك.
هذا نزل
بس ترى 4 خانات مو 3.
هذا خلصت. هاي الترجيح مع ال 55.
شلون يعني؟
رجعناها رجعت لنا هذا.
ما فهمت. الخانه الرابعه ليش؟ الخانه الرابعه.
نسويها بلون مختلف.
تمام.
عزيزين هاي الاخيره هنا 4 في 4 اكتبها 52 154 154 204 204 100.
ليش نزلت مضربهن؟
لا جمع مضرب جمع
اها
ال 154
ايه
154
جمع بس جمع اي
جمع بس
فهمت. بس نجمع محلوله. واجب نصا بالامتحان انا شايفه سلسله.
ما جواب يعني قارن الارقام شو صح.
صحيح تمام.
حتى لو صحيح.
هاي
عافيه ابن اختي.
كيف نسويها؟
زيد على
بس بس يجيب لنا
هو يجيب لنا هو اكيد الفلتر كامل. نجيب نصا للدخين. نجيب نصا. احفظ الارقام وهي للدخين.
ما أحفظها بس أحتاجها.
لا والله انا احفظها.
ما اعرفها.
خلي كمل.
Now we start with the vector of noise values. The size is the 100. And at last we want to reach to an image 64, 64, 3. 3 is the color, 3 color RGB. So now we see how we can do that. At first, we want to convert vector to this image, So we see how we can do it. If we apply one decombination, so from a vector, we can reach 4 by 4. How it is possible? Imagine we have this image, 4 by 4. This is slice of 4 by 4. So, a filter is applied here, the size of filter be 4 by 4. So, what will be the result? Applying a filter of 4 by 4 on an image of 4 by 4. The result will be
60
one number. I mean combination. How we do combination? We overlap the filter here. Filter also is the same size. So we multiply overlap pairs and then sum. It will be one value. Then there is not any place to shift. Right or down, there is not any place. It's finished. Just with one overlapping. So that means applying a filter for 4 by 4 on the same size image, the result will be one value. So also applying the decombination from one value will be one image 4 by 4. How it is possible? I I give an example at first. Imagine here we have 1, 2, 3, 5, for example. And the filter is 1, 2, 2, 1. So for the filtration, at first we put it here. So in one filtering, there is not any place to shift right or down. So just we do one filtering, and when we multiply the overlapped pair, here became 1, here became 4, here became 6, and here became 5. Then we added, became 10, 6, 16. The result became 16. One value, 16. This is the result of convolution. For the deconvolution, we multiply this one and this one became 16. If we do same 16, this will be the result of deconvolution. So as you see, the number are not same. To reach the same number, the filter should be different. Means if we want filter, we do convolution, we should find another filter to do the convolution. Means we have f minus f, means a function and inverse function. So here is the same. So if the input size is 1 by 1, the output with the deconvolution and filter size is 4 by 4 will be the size of the filter, 4 by 4. And how many slices we will have, as we say. For example, we say here, for example, this is the mistake, writing mistake. Starting is 512. So that's why we say produce 512 in the depths. It means we have 512 slides. So to do that, if you remember, we say we will have 512 filter. Each of the filter is 4 by 4. So one 4 by 4 filter converted and slice to one slice of 4 by 4, then we have 512 times replication of the process. We will produce 512 slices. And if you remember, when we say the filter size is 4 by 4, we don't talk about the depths of filter. We do in a way that all of the depths will be deleted. Means we will have just one slice for all depths. For example, if it is convolution, we will have this size and 100 in the depths. So all of them will be added. So we do a deconvolution of 4 by 4, and the depths we don't talk about because the same as the input. The result is, if here is the 1 by 1, after deconvolution will be 4 by 4, because if we apply convolution here to 4 by 4, it became 1 by 1. So we want to have 512 in the depths. That's why we apply 512 filters. So we will have with the same size slices, and depths of the output will be 512. So in the course we talk for the first process.
لاصق فهمت الفلتر؟ إيه؟ مويه مليوسة. مويه.
So here the code is this one. The deconvolution code in the PyTorch, the name is count transpose 2D, the name of the deconvolution code. So inside, we will talk about the parameters. So inside is a Z, here in the code is this one, I show here. This is the Z, a vector of random values. The size is, we type Z, we say Z. Here is the size is the 100. So, we get as input Z. After we apply this code, we will have this size. We will have this size, NGF multiply 8 multiply 4 by 4. So this 4 by 4 is the size that's the 4 by 4. And about depths, at first we produce NGF is number of generator features. It's a parameter. So in this code it's take 64. So number of generator feature is 64. Then 64 at first multiplied on 8. It's multiplied on 8 became 512. So that means we take a vector, the size is 100, we get at result, at output, 512, 4 by 4. 512 is the depth, and the size of the matrix is 4 by 4, like this. 4 by 4, and the depth 512. So, how we do it in this code? It has some parameters. If you remember from the codes of convolution, almost the same. Here, it says the depth of the input. Depth of the input is number of Z, means here is 100. All time the name Z put it for the vector of random value. So it's 100. So this 100 is depth of input, the number of slices of the input. So here is NGF multiply 8 or 512. The second parameter in the convolution code in PyTorch is the number of depths in output. Means this. In other words, it's number of the filter that we apply. So the next parameter is 4. The next parameter in this code is the size of the filter. That's 4. Means 4 by 4, but we don't talk about depths because depths is all time equal to this one, as you remember from the convolution. The next parameter here is the 1, means when we move the window, moving length, moving size is 1, means we put it the window, then we shift 1. If it is 2, we shift 2, means if we have here we have image. So if the size of the filter is 2 by 2, so if we have stripe, the name of the moving is stripe. If stripe size is 1, it means the next position will be this.
one shifting.
If it is 2, means the next one is not this one. If first we are here, the next one is starting.
Two shifting.
2 shift we will have. So here it says 1 shift we need, and the next parameter is the 0 here. It's the padding, 0 padding. It means adding extra 0 in the output of the inputs. Here it's 0 means we don't have padding.
Zero شو؟
So till now, if you agree, come here
وياش ست
and describe in Arabic, then you can change.
تشرحين بالعربي قلت.
No.
No, it's difficult.
انت ابن اختي قوم عندها صوت. قول اخلي عندك.
If you have any question, you may ask. We are talking just about this one. Takes this one.
لا انت ما في شيء. لا سؤال ابن داخل.
قبلها انه مالتنا اللي السايز يعني فالزت هنا هو يقصد بيها السايز مال الصوره الاصليه مالتنا وبناها بالقبلها اللي هو هذا الحجم مالته تمام؟
تمام.
اوكي؟ هسه ايش يقول لك؟ يقول لك هنا النمبر اوف جنريتور فيلتر هاي نمبر اوف جنريتور ومبانا اياه المفروض هو هذا اللي استخدم قبل الخمسمية 512 مال السلايدات تمام؟ لازم مالته وقال لك الثمانية هنا يعطيك الفلتر مالتك هو المفروض انه يعني يصير 4 في 4 قال لك لا ما له 4 في 4 يصير في 8 مالته الأربعة حجم الفلتر لما يكون سلايد واحد مو هو الفلتر قال لك انا اريد 4 في 4 لا نعطيها بس كانه جهه واحده ما اريد 4 قطع 4 1 2 3 4 4 ارقام بس تمام؟ والواحد هنا يقول لك انا اريد تطلع لي يعني لاين واحد يعني يطلع لي صوره واحده
الشفت ايش قد تسحب؟
الشفتنج مالته اذا انا سويت قوشين مسويناها مصفوفه كان الفلتر 2 في 2 والصوت كانت 4 في 4 كم شفتنج صار بها 4 شفتات يعني لانه انت فلتر 2 ب 2 وصوره 2 ب 2 ما بيها اي شفتنج يعني يصير رقم يا رقم فالواحد هذا انه احنا ما عندنا يعني بس شفت واحد كبرات اذا الله اياها 4 ب 4 مصفوفه فلتر 2 ب 2 حيصير عندنا شفتين بيها فرنسا مشرحه هذا شفت 2 بالخارج وهكذا اذا اكثر مصفوفه فلتر اكثر يعني قد شفت المصفوفه مالتك يصير هذا غير الواحد تمام؟ فلتر 0 وات؟
0 we don't have padding.
الزيرو ما عندنا يعني ما عندنا هذا
We don't extend the size of the unit.
تمام ما عندنا بعد يعني تكتفي بالحجم فنص ما هي دقة ثانك يو سو ماتش زينة
ما بختي.
والله يا اشتغلت.
شنو؟
The previous slide please.
Really good. You make it the size. Okay.
I think it just control Z will bug.
You are talking about this one?
Yes.
So this
The strategy we used here, but in the code, how make it's thinner?
now we are talking about
Yes, I just don't understand this. But in the code,
just now we talked about bomb process.
Yes.
Do you have any question in this part?
No.
So the next part we are coming. Wait. Okay. That was just for the first part. We converted Z to an image with the size of 520 in the depth, 4 by 4. So you don't have any questions. Now we are going to next part. We try to convert the 4 by 4 with the 512 to this in this depth and the size.
which make it
Double.
bigger size but thinner.
So that means we converted this one. So 456. It means NGF 64 multiplied became 256. And the size of the image 8 by 8. We need the code to have this. The code is this here. This code, the combination code, do that. We see how it is, how it do this. So here, at first, the size of the depths. Size of the depths is NGF multiplied 8. Became 512. So the size of depths of input is 500. Then the size of depths of output. It's half size, means 256. So the output depth is 256. How it is doing in the mathematics side? We do filtering 256 times. So this number of slices is 256, or in other words, we have depth size 256. So then filter size is 4 by 4. And shifting is 2, not 1. And padding is 1. So we extend the size of image 1 in each side, means in right 1, in left 1, in up 1, in down 1, means, for example, in the row we added 2. 1 on top, 1 on down, and so on. So we see what happens. We are doing the combination. We see with the combination of this one, we can have this or not, because it's more much more easy to understand. So that's why we do in the inverse one. So here we have a 0 padding, means we add 0 in all sides with the size of 1. So that means the size became 10 by 10 instead of 8 by 8. And shifting is 2 and filter size is the 4. We see what happens. We have a image, the size is 10 by 10. So at first we put a filter, size is 4 by 4. After putting the filter size 4 by 4, how many we left here? 6. Is it correct? 6 and 4 became 10. So, at first we put it here, then we want to shift and put the next part. If we have one shifting, how many shifts we can have here? 6 shifts we can have here. 1 shift, 2 shifts, 6 shifts we can have.
Now it's 3.
Now, if the shifting size is 2,
3 shift will make.
how many shifts we can have here?
3.
3. So 3 shifts we may have here, and 1 at first time we have here. It became 4. The size of output became 4. What we want to have? 4 by 4. So with the 8 and making filter size 4, it's not depend on 8 in any size. If the filter size is 4 and we shift 2 by 2, then the size will be halved. We will have half size in this side. So this one we make it the depth half, but the size of image 2 times. The same code we will repeat till end. The same this code. We see. Now we have here in the code the size 8 by 8 and the depth is NGF multiplied 64 multiplied 4 became 256. So after the same code, repetition of the same code, we make the depth half and the size 2 times. The same. Also here we got so here
ايش انظروا ايش should be 128
wait.
28 خبيث 28
128.
yes.
So, and the size of the image became
So 16
16. We see it's possible. So here we have the filter size 4 by 4 and shifting 2 and padding 1. So padding 1 make the 16 change to 18 multiplied 8. Is it correct? So after that we use the filter size 4. So when we put 4 here, so the extra will be 12. Sorry, 14. 14 and 4 became 18. So if we shift 1, we will have 14 shift. If we have shifting size 2, here we will have how many shift? 7 shift. 7 with 1 became 8. Became 8 by 8.
أزيدين ليش 28 كلها؟ ضرب شنو بشنو؟ ليش 28؟
118
22 ليش؟
هي الرامات ايش
قسم
قد؟
على 2
مو شايفين؟
شنو الشرط؟
فهمتها الصراحه يعني بس ما اعرف شو اصير
ما يخاف نزق
خلي كم الحين بتكون 60 صفنتها هاي تخوف
شو؟
صفنتها تخوف
ليش؟ مو هي الرامات
ما عليها
لا
بالبعض
لا الهاردات بشكل عام 512 64 لا ثابته اسال
Is the number 512 then 256 is it fixed or changeable؟
Changeable. It's depend on the NGF size.
ايش يفتح؟ مو ثابته.
But every time we make it half.
I mean in other example maybe it's different.
No, every time we make it half, it's fixed. But the number of NZF can be different.
Yes, I mean maybe.
Starting value, this
Yes,
value
I mean
is-
this. Maybe it
It's,
be
it's changeable,
Yeah.
but every time we make it half,
Half.
it's fixed.
maybe 500 and become 250.
يعني يعتمد على الرقم الناطق 500.
So now we
يجي
have
600.
16 by 16. Also we do same. We make it the depth half, the size 2 times with the same width. Now we have this one. We apply. We say here the input. We have. $64. Now we apply this code. What say this code? It say the depth of the input is NGF, means 64. The depth of output, we say this depth. This generator, so here it say the number of the depths in the output became NC. Here in this example is 3. Because we want to have an image, the depth is 3 RGB. So we say NG is the depth of output. So here the depth of output became 3. And we apply a filter size 4 and the same filter, same shifting and so on. So it makes the this size 2 times. So between 64. So the size became 64, and the depth as we said. That's here 3.
مو مش عارف مسوي.
ما يعني فتحت بس ما اعرف شلون اوصل.
اي وصل ما ان شاء الله كذا غلط.
لا لا
حتى لو
Mama, you are very struggling.
وياك عز الدين.
Atufat Araplara değil ya.
الفلتر والشيفنج والشكل والبديل المعروفات تمام شكل بس ظني من 16 ولا 30 ولا 64 سوى اول حاجه عندنا الاربعه ب4 عشان 501 و512 ها هو تخيل انه الصوره تمر بمراحل كل مراحل مده تزيد مثل داخل الفلتر ماخذ الدنك ماخذ العمق مال الفلتر ماخذ ماخذ اول حاجه عندنا اربع عشان 512 ورجع سواها بالحاله الثانيه سواها كان 8 قسم 512 قال هاوس سمعت 2 صارت 256 بالحاله اللي وراها صار 16 قسم 256 على 2 صارت 128 بالحاله الثالثه صارت 32 هم قسم هنا صار 64 رجع قسمها لنطلع صار 32 لانه انا عندنا 32 اخر شيء حيطلع هاي انسي هو الاوتبوت مالتك تجيب مع اوتبوت مالتك وال 64 حتطلع يعني هاي مالتك ثلاث لاينات بس وفلتر مالتك الاخير.
كلش ممتاز. بس طيب ايوه
64
ليش؟
ضلها في اثنين ضلها في اثنين دقيقة يعني كلها فكل ما يضربها زي مالتك الفلتر. هسه هاي
The whole
32
just to make this first stage. The last stage will become here.
What is this? Wait.
هاي هسه بدي اخذها هيجي ناخذها
ايه كان هاي هيك الصورة كانت ورا صارت هيك هذا ابحث
Wait. Oh, this generator. What is the top of generator? Starting from a random vector, produce a generate an image. So start every time start from random, but here the filter is different. So he trained the filter in a way that can generate Chinese images. And so on. And of course, in a game and in a cooperation with the discriminator. So it's a game. Two sides try to improve each other. In the last, the generator improved and can generate fake images, but very look like very real.
شلون حالة الوجه الشخص الصيني؟ هم كلهم مشابهين بس تقدر تميز بين واحد يعني هذا الفيك يعني مزيف بالحقيقي. لما تشوف ناس وايد صينيين تميز انه هذا في اختلاف مش بسيط. هذا الفيك يعني معناته تزييف. تميز بين الحقيقي والمزيف بهاي الحالة. هسه هو منطقي هاي الفئات ما بدك اياها نفس الحالة تقسيم. طيب احنا عندنا بالداتا ال 1024
1 تيرا
هي 1 كيلو اللي هي 2 أس 10 تمام؟ يعني احنا اخذناها يعني بالمحاسبات
1 تيرا 1 تيرا بايت
1 كيلو 1024 1 كيلو 2 أس 10 2 أس 10 اضربها اسويها نفسيها لما تجي كل مره هذا قسم 8 قسم على الهاو 16 قسم على الهاو قسم على الهاو لحد ما يوصل لثلاثه.
بس هذا يبقى كمثال هذا ما مرتبط بالجماعة الوسطى.
لا هذا هو اللي
ال 1024 ممكن ينطيك اياها 2000 مو ثابت.
ثابتات
اللي هاي كيلو ما عليك
ما
ما شيء القيم هسه هاي كيلو هاي نص كيلو انت بالداتا البايت هي ثابته هاي
اعرف بس ممكن اعطيك اياها 1050
حسب ما نعطيك اياها بالسؤال اللي كان مفصل احنا نعطيك اياها فيربل هو يعطيك اياها بالسؤال يعني اول حالات تكمل عليها انت اهم شيء تعرف انه شلون تصير التقسيمات مالك
ذي ثابتات ال 8 وال 16 وال 32 وال 64
حسب الاربعه نعطيك اياها بالسؤال.
يعطيك هو 4
شلون؟
العفو الاثنين مو مكتوب هاي اثنين
اي
اكو بالسؤال تلقاها اللي يروح لك على الكود
اي
هسه هو
اربعه ما في اثنين في واحد البادنج
إيه.
الشد
إيه.
اكو رقم تلقى اثنين هو اللي ايش قد تضرب
كلمه تضرب الفلتر
اها
اول فلتر مطلق اياها 2 في 2 فتم مسوي 2 لحد ما وصل ل 64 يعني 2 اس 2 2 اس 3 اي
جزء يعطيك اياه بخمسه تقعد 4 في 5 يطلع لك الناتج 20 ما في 5 يصير 100.
2 في 3 2 في 4 2 في 5 لحد ما وصل
Just the number are not correct. Here is 512.
اوكي
Here
ما في سجل نص
and so on. 112, 256.
دكتور this 112 fixed
No,
لحد بالألف
this is not correct.
no
This should be 512. This is not fixed. See, here we have NGF, number of generator features, means dimension, above. So, it's depend what we take it. Here they take it 64. So anytime they say NGF, the out of generator is 64 multiplied 8 became 256. If it is 128, it became.
يعني ينطيك قيمه الان جي اف بالسؤال تنظر فيه
تضربها في 8 وتبدي تزايد وتقسم على 2 لحد ما توصل لحد اخر شيء 64.
And here is discriminator. The discriminator use convolution, not the convolution.
Okay.
So try to convert an image to one value. If the after training, if the input is real image, the output is one. If it is the fake generated with the generated one, then in that case it's the zero. The output.
شلون من
Now we talk about-
سويناها الجنريتر الجي حولها بالعكس من قبل شوي من سويناها فرجع يسوي لك اذا كانت قيمتك واحد وصل يعني ريال اذا الصفر هي الفيك المزيفه ترجع بالعكس تضربها.
So, at first we have an image. The input is 64. The depth is 3.
هسه اكسر الحالة.
So here, the NC means 3 here. We have 64 multiplied by 64, the size of image and depth 3, RGB. With this code, we try to make it to this one. The depth became discriminator features, means number of discriminator features, means other discriminator. So, every time we make it the size of the image half, smaller. And at first we make it MDF. So, the text is MDF. And the size became half. To make that, we use this code. We say, if you remember the same code, but the combination we had in the previous slide. For filter size, shifting 2, and one padding, make it half. We tried just for the first one. So x 64, here, sorry, 64, we pad 0 in all sides.
البادينج.
So the size became 60 size by 60.
اي طول.
Yeah. So the size, for example, here is 60.
بس.
So at first we put AM filter 4x4. So how many left for here? 60. If we shift 1 by 1, 62 shift we will have. If we shift 2 by 2, 31 shift we will have here. And also one position at the first became this one, 62, 60, after applying this one. So, also we say the number of the output. Dimension is NDF. So, the number of dimension of the output became NDF. After that, we use this code, this one. It's the same to make it half. So we repeat the same code, we make it half. We repeat the same. So at first it became, when we make it half, it became 16. And here, the depths every time we make it twice. Here is NDF. Here we make 2 NDF, or the depths means this number filter we have. this number is sliced as a result of its filtering we will have. So here we have 2 NDF. And the result became 1660.
اوكي.
The same function we applied, the result became half, 8 by 8. And the dates we say NDF multiply 4. That's why the dates became twice. 4 NDF. Then with the same code as an input we have this one, we will have. The same code make also have an NDF multiply 8.
4 by 4. Four.
So after we reach 4, if we apply just one filter 4 by 4, the result will be 1. What we are looking for. Here we say, after this stage, we say the NDF, the dates, we say the input depth is NDF multiplied 8. But the depth of output, just we want to have one number, so we make it depth 1 in the output, 1 filtering we apply, and with the 5 and 1 shift and 0 padding, this one with 1 filtering 4 by 4 sitting here, no way to shift, so just one value will be in the result, 1 by 1 image, and the depths we told in this code be 1. So we will have 1 number. We build a model, neural networks, input is an image, output is just one value. So it will be trained every time the image is the real, 1 from the training data, it will be 1, in other way it will be 0. In a time generative, make it himself powerful to generate images that even they are fake, but the discriminator will be deceived and the result will be 1. So it cannot recognize the input as generated one. Instead of that, it thinks the input is a real. Because generated very real, look like images.
بالدعوة اشرح لنا. شوف انت قوي.
عندي مدرسة بعد.
تمام.
مو عزيز
So
سبع.
this chapter is
ممكن خلص الشابتر.
what time is it?
11 and